about the future application use case, especially beyond 5G and verticals. First, I have some slides more from the Nokia Bell Labs perspective, as the Hexa-X EU 6G flagship has just started, and concerning these use cases, we will have more to tell, and we are publishing a document on these use cases early March. So only about a bit more than 1 month, and then from our website you can download much more information about our collective understanding on these use cases, and I can promise you that there is a kind of a lot new interesting content on top of what I say, but I hope that already what I say there is interesting content. So smartphones have been with us for quite some time, and then they are a very good user interface and good for our industry. That as Arno was saying, so all the people kind of can't get their hands out of them. So very active usage. One question here is that would the time in the time frame of 6G be already good timing to go to some more advanced user interfaces, so that you would not need to have the mobile device always in your hand, but you would have some more intuitive ways of interacting with the data and with the connectivity. Integrate the things to your textiles, maybe even skin, but in some multiple ways to your body. Most likely for people with no impairments, body implantable devices, I don't think that they would be any mainstream, and I don't know if for people with no impairments they would kind of be so interesting or winning as an opportunity. But for people with impairments, for sure, there has already been quite some time research on those, and for like non-impaired people in some special circumstances, they could also be very good approach. So we are seeing the much more wider spread and use of digital worlds, and especially now during the COVID times. So there is always value from kind of physically meeting other people. So if we have met once physically, it is easier to then interact remotely as well. But there could be ways for much more enhancing this virtual presence, so that during COVID times we could use all our senses and be kind of much more in depth and in a more realistically feeling way near to each other and interacting with each other. This mixed reality co-design, so also interacting with physical and digital reality. Then we have the augmented intelligence, we have artificial intelligence, machine learning, lots of good development there, and these combined with the better availability of data. So we can then see that how the different machines and how the different devices of ourselves could augment our operation in very many different ways. And this, with respect to these machines, so also automating the operation of robots or teams of robots to work with us. So how could we have 6G to enable a new lifestyle at scale? For traffic, this has been heavily studied in the context of 5G, and for sure benefits to be expected with 5G here, and already with 4G one can reach benefits here. Then thinking about very high density of people and cars and devices needing connectivity, maybe high amounts of data if there is video from from many of the vehicles, from the vehicles and to the vehicles. Then if also there would be information with the radios for other purposes than communication. So then maybe all of this combined, so we get a shortage with what 5G can offer. And here then also, yes, positioning is coming with 5G, but what other information than positioning, and how much can we improve that? What kind of opportunities there are in that direction? Again, this telepresence, so I was already talking about that, and as well as this mixed reality. So you could interact with other humans, you could interact with physical objects near you and near others remotely, and with the digital representations. So you could kind of build and design and plan things that don't exist or partially exist, and partially exist here and partially exist somewhere else, and do this with other humans. So what kind of opportunities does this raise, and what kind of requirements does this then put for connectivity? So central item here is this interaction between biological, physical, and digital worlds. So biological world, so us, we would need to be in control, and we would need to be in having efficient human-machine interfaces to the physical world to control the physical world. Models of ourselves could be built in digital world, for example, for preventive healthcare, to prevent, for example, heart attacks, or recognize any other suggestions from the health perspective. And as well with the physical and digital world, one would need real-time synchronous connectivity in order then to build models of the digital world. Now we have the digital twins, but to take this to a much more massive scale in order to be better able to plan and operate the physical world, also from this preventive maintenance point of view there as well. And then here some technology central for this. So this precision sensing, actuation, widespread computing and access to it, knowledge systems, so the widespread use of machine learning and human-machine interfaces. So 6G to unify the experience across physical, digital, and biological worlds. Then, obviously for all of the generations, one item is to further expand what can be done with previous generations, and to get more of the same. And certainly that is of high value. We are expecting the traffic further to increase, as it has been, and has been a main driver for one of the main drivers for all the generations. But of course, it's more interesting to think that what other things that were not in the previous generations, what to expect from those. But here some numbers in this continuation, but also some new dimensions here with this, for example, with the additional possibilities for sensing. Once again to mention that one, and then when we are pushing to more and more, so we should be extremely cautious about sustainability. So how can we do this with less and less energy consumption? There is Nokia has made a release recently showing about 90% energy reduction from 4G to 5G, but we need to continue on this track and see that how could the technology be used in a more sustainable way, how could we compensate, but also how could the technology help other sectors of human activities to be more sustainable in those areas. So 6 key technologies for 5G, AI, ML, new possibilities of using spectrum, so needing there is continuous need for more traffic, so need to look at the higher spectrum, but also how to do things in a more clever way at low and mid bands. Network as sensor mentioned, how to look at the new network architectures, and this extreme connectivity referring to this more the same, but also pushing the boundaries of this URLLC even further. And as more and more aspects of life go digital and wireless, so the security and trust needs to be taken very seriously into account right from the very beginning of the new generation. So each of the generations have had their stories, and so we don't of course yet know what is the story for 6G, but here some aspects related to this that I have already been covering. So we see 6G to unify this experience across physical, digital, and biological worlds, and central technologies here: ubiquitous computing, this AI, sensing, and listed here as well. So repeating what was said before, but then a couple of words that at the moment can be said about this EU 6G flagship Hexa-X project. So the vision, the starting point for the vision, and this we are developing further in the project, is this interaction between the three worlds, as I have been telling. But then based on this in the project work, then we have been looking at what kind of research challenges come out from this. So I already highlighted this sustainability. Network of networks I didn't yet touch, but so we are expecting some connectivity from the human perspective, so humans can have their own networks or groups of humans. Same applies to machines or groups of machines. And then looking at some earlier research items and potential new ones, in what way to best arrange the network, what would be good network architecture. This connecting intelligence, so when we are designing a new generation right from the start by looking at this AI ML, so how would we do that? Trustworthiness, already highlighted, this extreme experience, so pushing further the envelope. Global service coverage, very essential from this, also this sustainability and inclusion point of view. How could we get all these services in a cost-efficient manner to all parts of the world? So we have 5G, we have these research challenges, and then how are we going to answer to those research challenges? So there is lots of interesting technologies we could be studying, and we kind of are giving some attention here. So here kind of wide set of many keywords, so further distribution, higher amount of antennas, there further potential physical separation from each other, going to higher frequencies, and then how to have devices that somehow get the energy for the operation, either from other parts of the system or from outside of the communication system. Further helping with this sustainability. So we are building the foundation for this end-to-end systems towards 6G via then connecting all the technologies with this X-enabler fabric, looking at this radio performance at all the frequencies, but then the most novel work in the towards the terahertz bands. This AI ML network of networks, and with all of this, the impact creation towards 6G. So need to look at this interaction between the worlds as a source for these use cases, and look at the roles of these different identified trends. And with the timeline, so we are a 2.5-year project, just started now January this year, so lasting for 2023 summer. And now we are at the phase of 6G structuring and framing, and we are coming from this last call of the current framework program, and then targeting to be the basis for much wider set of 6G projects in the future in Horizon Europe, and then technical standardization later part of this decade, and at the end of the decade to see the steps towards the commercialization. And here is the set of organizations involved in the project, and so this is the presentation I was planning to give. So any questions or comments?
Well, thank you very much, and I'm happy, even if Benelux is missing in your consortium, that you were willing to talk to us today and give this presentation. I have noticed two small questions. I think the first one is, what is a stretchable? In slide 2, what is meant with a stretchable?
Yes, so one challenge in having some user interfaces as part of textiles or part of something that we humans are wearing. So part of the challenge is that, for example, in order to have comfortable clothes, they need to be stretchable and flexible. And there has already been quite some time research on how to embed electronics as part of, for example, textiles. So this is related to this flexible and stretchable in order to be then like a better part of some things that we have with us that would be more intuitive to use than the current devices. Okay.
And then another question was whether you also plan to use LiDAR. I think that is probably connected to a lot of sensing capabilities that will be integrated somehow.
Yeah, so we here kind of from the research perspective, as said, so one item is to see how communication devices could be used to get information other than the communication, but then all other information that would be available, we should seek ways how to use them, and certainly LiDAR, we should take that also into account.